All right, for number 13, it says, given this proportion, A over B equals 5 over 19, what ratio completes the equivalent proportion A over 5 equals what over what? Well, there's this neat little thing that we're able to do. Since if we took this proportion and we multiply the diagonals, we get A times 19 and B times 5, right? A times 19 and B times 5. So we're going to be able to get an equivalent proportion as long as we keep A and 19 on the diagonals and we keep B and 5 on diagonal positions, so that no matter whether B is here or here, it's always going to multiply with the other number 5, which is going to be here or here. Okay, so it's okay if they switch as long as they stay multiplied A times 19, B times 5. So what we're allowed to do is, let me erase what we got over here. Okay, what we're allowed to do is switch the position of one pair of diagonals in order to get an equivalent proportion. And what we're going to specifically do, because we want to get A over 5. So we want A to stay where it is right now, and we want B and 5 to switch so that 5's on the bottom. So what we're going to do is we're going to switch these two, and what we'll get is then A over 5 equals, and what's going to go on top, the B is going to trade places with the 5 to become B over 19. And what they're asking is A over 5 equals what? And we see that it equals B over 19. That's B. Okay. This one's a little bit, take a little bit more to explain it. So let's take a minute to explain this. Okay. I'll move this up here. And actually, I'm going to move it and draw a line just to give us some space to work. Okay. So how does this work? If you took x over 3, let's just say x over 3, and you had on the other side something like y over 2, and we knew that they were equivalent amounts, we could say, okay, if essentially that's some fraction that's equal in value there on both sides, then conceivably we could then say, okay, now what I'm going to do is I'm going to add 1 to both sides, and since they were equal, they should still be equal. Forget about why I'm doing that for a second. Just acknowledge that that's true. That if you had two equal amounts, the x over 3 and the y over 2, if we knew that they were equal, and we did because they have an equal sign between them, and I'm telling you this, I'm setting this up, then if they were equal and you added 1 to both sides, that's a legal move in math. You're allowed to add the same amount to equal amounts, and they will stay equal. Okay, so why do I want to do this? Because actually, if instead of writing x over 3 plus 1, we wrote x over 3 plus 3 over 3, because that's equal to 1, but that's got the same denominator. Okay, and let's do that same thing to the other side. On the other side, we had y over 2, and it said y over 2 plus 1. So what could we add to it that had a 2 on the bottom that was equal to 1? Well, 2 on the top and 2 on the bottom, that equals 1. So you're allowed to, what we're doing then, let me change the color there so you can see that a little better, what we're matching up. Okay, so we're adding 1 to both sides. That's what you can see here with the light blue. We add 1 to both sides, and then we rewrite the same thing, but here we're adding instead 1/2, the 1 that we're adding in a fractional form, which isn't a different amount, it just looks different. And now they have the same denominator. So now what we're allowed to do is we can give them both the same denominator. Pick another color here. Let's give them both that 3 that's on the bottom as a single denominator, and what we do on the top is we say x plus 3. This part becomes the numerator. And then, since they both have 2 on the bottom, we can just say it has a single 2 on the bottom, and we can take that, y plus 2, put it on the top. And you get an equivalent amount from what you originally had, which, if I took away that plus 1 here, and that plus 1 there, you just get x plus 3 equals y over 2. Let me rewrite it because I erased it by accident. So if you can add 1 to both sides and end up with this on the bottom, then if you started with that and you subtracted 1 from both, you would end up with that. Okay, so essentially what you did is you subtracted 1 from both sides. And if I was to shift this up and write what that would look like to say, okay, let's start with that then, you could say, well, x plus 3 over 3 is just the same as x over 3 plus 3 over 3. And, of course, same thing on the other side. Y plus 2 over 2, you can just split that up so that they have the same denominator, but they are 2 different fractions. Y over 2 plus 2 over 2. And then a legal move in algebra is to subtract 1 from both sides. When you subtract 1 from both sides, that's essentially what this is 3 over 3 or 1 minus 1. And 2 over 2, or 1, minus 1. So you're taking that amount away exactly and leaving you just with x over 3 equals y over 2. Okay? So when we look at what our choice is, it says x over 3 equals, this is what it says up top, x over 3 equals what? And we know that x over 3 would be equal to y over 2. And that's answer C.